Hi everyone, welcome back to Workshop, and it's repair time again. Well, actually it's repair and refurbishment time, and this time I've got my hands on a Time Electronics DC voltage calibrator, the type 2003S. This is a 0 to 10 volt calibrator which probably came from the early 80s, something like that. Now, I picked this one up purely because I like the form factor. Plus, I wanted to get my hands on a little bit of a refurbishment project. And this unit looks okay from the outset, but if I just tilt the camera around, maybe you can see, actually, the front panel's been pushed in. I think it's probably been dropped on these banana sockets here, and it's pushed the front panel back in. So obviously I'll have to do something about that. But what I'd also like to do is give it a real good clean up, maybe even paint the case here, because it is a little bit rusty and grubby and all the rest of it. And this here also need looked at as well. The front panel skin is actually coming away right along the bottom there. But obviously the first thing I'm going to do is let's see if it's working. Let's open it up, take a look inside, make any necessary electronic repairs, and then move on. So how does it work? Well, over the left hand side we've got 5 thumb wheel switches, basically for dialing up the voltage output that you want. And over the right hand side we've got a range selector switch, and that gives 0 to 10 volts at the far left here, right round to 0 to effectively 1 millivolt, and curiously with a 0.01 microvolt resolution there on this far right hand thumb wheel switch. Now that is way down in the noise, so how effective that is or accurate I don't really know. Now this is a mains operated and battery powered unit, so in battery powered mode you're going to take away any mains borne noise that may appear. So yes, it will be able to go down a little bit further in terms of removing noise from the output, but even though 0.01 microvolt is a tall order. You've got the mains on-off switch here, and you've got an option here for actually reversing the output on the output bananas. And over to the left hand side we've got a battery level indicator. Now it is actually showing it dead. That's not surprising, it's probably been sitting around for years. I don't even know if there's any batteries inside it. So anyway, let's tear it apart and let's see what we've got inside. Looks like we've found the battery pack. Our power supply as well, I think, because the mains cable comes in the back here into this housing at the back, and then you've got 2 wires going away off inside. So I think you've got the power supply and the batteries in this rear cover here. So I'll just pull them off. There we go, I'll put that to one side just now. I'll get that later. Let's take a look at this thing here. Okay, we've got 4 Phillips screws there holding this plastic cover, so I'll need to take that off. Okay. And there we go. Inside the unit there, you've got some sort of cover over the top of the main PCB inside there, and you can see the rear of the thumb wheel switches there with the various decade resistors on it, and they look fairly well intact. Looks like they're conformal coated, so that should be okay. So it looks like we need to remove the 4 screws in the front in order to get in a bit further. And you can see the main PCB here that mounts the front range selection switch in there, and there's a few other components, but interestingly you've got this connector here up onto this back module here, and this is potted. And that's obviously where they've tried to build their stability from. And there's a couple of pots down on here There we go. And they're marked in the back 0 in calibration. So yeah, just hope that if there's any fault it's not inside there. Otherwise we might be trying to do a de-potting job. There is some fuses and some other pots around. I do have the schematics for it, so if we need to make any sort of repairs or do anything, then we should be able to. But I'm not going to strip this down any further because I do want to power it up. But let's take a look at the power supply and the batteries and let's see what we've got there. That's the cover off. Wow. That power supply is in a bit of a mess. You can see that the batteries have leaked here and it's just completely coated that circuit board. And there is actually, it looks like a 12 volt regulator, is it? Let me zoom in there and let's take a look at that. I'm not sure it's a regulator. It just says 70 MC78 something, but I can't quite read it at the moment. We've got some insulating tape round something. I suspect that might be a coil, and it's also been tie wrapped into place as well. And the circuit board is really just a mess down there. Everything's absolutely coated. And there's quite a bit of rust on this transformer here, which again's got insulating tape all around it. So yes, I think the first thing we'll look at is trying to get this power supply up and running. And interestingly, if I turn it round, good old tested stickers, 20th of March 1979. Hello KC. So here is the schematic diagram for the power supply. Transformer at the left here, bridge rectifier, and it is actually an 18 volt regulator in that TO220 package. Then you've got the charging circuit here, you've got the batteries down here, and you can see you've got some blocking diodes here so that the batteries, when fitted onto this connector here, can supply power right through when the mains is turned off, and when the mains is turned on you've got 18 volts coming down through here, through the fuse and to the main board. So it's a simple 741 op amp and a BD131 transistor. It's a fairly simple circuit for charging the batteries, so we should be able to get that up and running once we've cleaned up the PCB. So the strategy for cleaning up the board, I'm actually going to remove the transformer from the board so that I can pop the board into my ultrasonic cleaner. Of course I'll remove the batteries as well, and at least that'll get rid of most of the corrosion and green stuff that's all over that board. So let me go and prepare that and I'll come back. Well, there we go. That's the power supply board disassembled. The batteries, well, they'll go straight in the bin, I think. The transformer, no, that's 100% savable. Only got a little bit of corrosion around about this tab at the bottom there. The rest of it looks pretty well intact. And the board itself, well, yes, as you can see, that's quite a mess. But take a look at the underside. Yeah, how much copper is left on those tracks, I don't know. But I'm going to stick it in ultrasonic cleaner and let's see what it looks like afterwards. Well, that's coming up quite a treat. I think thankfully all the copper tracks were actually tinned. So the corrosion from the batteries just looks like it's managed to just sit on top of the solder. That all the tracks had been tinned, apart from maybe one or two that need a bit of a tidy up, but 5 minutes in ultrasonic cleaner and a little bit of a scrub and it's coming up quite a treat. But a little bit more to go yet, there's still some green there, so I'll put it in for another 5 minutes. Well, there's the board all dried off. A little bit of work to do with the fiberglass pen, I think, just to get rid of some of the residue, the green deposits there that you can see, and a couple of unsoldered joints I notice as well. But I think this is savable, absolutely. Whether it's electronically intact, I don't know, I will need to beef up some of those tracks. There does look to have been a little bit of corrosion there, so I'll probably just run over every single track and just put a layer of solder on them, and perhaps some links where necessary, where the tracks have been eaten away. But it looks pretty good. Well, there it is. Looks a little bit like a dog's breakfast, to tell you the truth, but the problem is those tracks there, all of them just wouldn't take solder. I first of all tried this one up the right hand side there, and just it's like there was no flux, it just wouldn't go. So I'm not sure if it's just a consequence of the corrosion or something like that. I'm not really sure, but I've managed to repair the worst ones where there was breaks, like this one here, and this one along the bottom, and they're all intact. Yeah, it's not pretty, but hopefully it's functional. And what I will do once I know it's working, I'll put a conformal coating on it, both sides of the board, just to save it from any more corrosion. And on the top side, it's looking pretty good as well. Managed to get rid of the corrosion, the little bits that were left over. Well, there we go. I've jumped ahead and given a right good coating of conformal coating there. You can see it glazing in the light there. And that should hopefully keep it free of corrosion for a few more years yet. Okay, now before I strip this down and try to straighten out the front panel, etc., I thought I'd give it a test, see if it is actually working and see if there's any repair work needed here. So I've hooked up my multimeter to the output, and let's get it prepared. There we go. Now I've got my DC power supply, my bench power supply hooked up. I'm giving it an 18 volt supply, which is round about what it will end up with. And let me put power on. And let's just switch it on, keeping an eye on the current on the power supply. 14.5, 15 milliamps. And the meter's reading 0, and I've got 0 dialed in, and I'm on the 0 to 10 volt scale here. So let's just give it 1 volt and see what happens. And yes, that's not bad. Now obviously I haven't let it warm up yet, but yes, that's not bad. How about 5 volts? Yep, it does need calibration, but so far so good. And how about 1.2, 3, 4, 5 volts? Yes! And how about that reverse switch here? It's on normal at the moment, so if I go to reverse, should be minus 1.2. Yes, that's not bad. Let's try next scale along. It should shift the decimal point. Yep. And into normal mode. And shift the decimal point again. Yep. Again. Yep. And the far right hand scale. Yes, as you can see. So let me just put it on millivolts here. Should be able to pick that up a bit easier. And if I just zero that on 1 volt. Yes, 0.1 millivolt. And if I go 0.5 and well, that's about as far as this multimeter is going to go. I really need to hook up to my bench multimeter in order to get that extra resolution to find out if these thumbwheel switches here for the 0.01 microvolt resolution is going to work or not. But so far so good. I think this unit's working. And how about that battery level indicator? Well, at the moment it's off the scale with an 18 volt DC input. So if I just reach over and lower that down, 17, 16, yes, it's coming down. 15, 14. Yes, that looks like it's working okay. Down to 10 volts there, and we're into the red. Well, I think the next thing I'm going to do is repaint the actual enclosure, the back panel, and the front panel bezel here. Give them a chance to cure, A little bit more stripping down to do. Got to take the feet off, the handle off of here, and also see if I can get this rear panel sticker off in one piece. I'm going to use a blade to take that off. I've got a grommet to remove here as well, and then I'll rub them down. I won't bother filming that, it's done in my other workshop, and then I'll come back. Okay, with the paint drying on the main enclosure, it's time to strip down this front panel, and let's see if we can straighten it out, and also remove this sticker at the same time. Well, there we go, it's up and running, got the batteries fitted, and it's currently charging very nicely. The constant current, 5.7 milliamps or thereabouts, and the voltage across the batteries is currently about 16.8 volts, so that's within the window for the number of cells that I've got. So everything's great. However, there's a little bit of an issue getting there. And that is, I fitted the batteries, powered it up, and the batteries were charging, and then they weren't charging, and the rate was all over the place. Then it was back feeding back to the circuit board. It was doing all sorts of weird and wonderful things. But I finally got to the bottom of it. Now, if you remember, I think I've mentioned that the manual and the schematics, etc., have a little bit of a disagreement in terms of the number of cells. It says that it's a 10-pack cell fitted. However, the schematics, I think, mention 11 cells for the power supply. And I thought that this item here, which I've removed from the board, I thought that was a capacitor or something like that, or perhaps a diode, a low drop diode, because it's in series with the external battery pack. But it's not. This is a single cell. This is the 11th cell. So Time Electronics have fitted one cell to the board and then have a 6-pack fitted externally. And this one here isn't leaking. Now, whether it's any good or not, I don't know, but it's not leaking. And therefore, it was doing weird and wonderful things in terms of the actual circuit and the charging. So I've removed it from the board because I don't need it. And now I'm getting it charging nicely now. The circuit's up and running without that fitted. However, one thing I did break, the potentiometer. As part of the process of trying to get to the bottom of the problem, I was adjusting the potentiometer on the board and I broke it. It cracked. Probably old plastic, 1975. Yeah, so I broke it, so I've had to go and fit another one I've just happened to have in stock. Not the right package type, but it'll do nicely. So it's up and running now. I don't know the states of those batteries that I've purchased. I bought them off eBay. New old stock. Old stock is probably years and years and years old, so whether they're any good, I don't know. Okay, so whilst I was waiting on the batteries coming in, I thought I would just go ahead off camera and pre-calibrate the unit to my 3446-1A. And what you've got is a number of potentiometers on the top of the unit there on that PCB, which are used for calibrating the various different ranges on the selector switch on the front. Now there's only 3 potentiometers because a couple of the ranges share the same potentiometer. Now I managed to calibrate in the 100 millivolt scale, as you can see there, 1 digit out. I maybe need to tweak that, and also the 10 millivolt scale. I've managed to get that dialed in. However, the 10 volt scale presented a problem, and that is I've run out of number of turns on the actual potentiometer. If I just go and adjust VR4 here, adjust it this way, it's going up, and adjusting it that way, that's as far down as it'll go. So we've got a problem. So I dug out the schematic diagram. Let's take a zoom in on this area over here. Now this is the potted module in the back of the unit there, and then you can see SW2, that's the range switch here. So position 1 on the switch is a 10 volt scale, position 1 there, and if you follow that down through a couple of resistors there, there's VR4 that I was trying to adjust, a 1 mega ohm pot, and in series with that is a 2 mega ohm resistor. With the pot right round one way, the resistance across the pot is at its maximum. So therefore, it looks like I'll possibly need to replace or check the spec on that 2 mega ohm resistor. Maybe it's out of tolerance now, or perhaps increase it slightly. So let's take a look at the PCB. There's VR4 there, and very conveniently, there is R13, that 2 mega ohm resistor. Now I should be able to unsolder that at one end and lift it, and then check its resistance. And whilst I'm at it, I can check the pot as well, just to make sure we're getting the full 1 mega ohm with it fully clockwise. Okay, that's a resistor lifted at one end, so let me just get in there and measure its value. 1.96, and that's not too bad. Oh, bad connection there. 1.96. And the potentiometer, which is now open at one end as well now, 0.9. So I think a combination of both of those being low, the resistor and the pot, has contributed to running out of adjustment on that potentiometer to bring back in the 10 volt scale. So I'll either need to replace the resistor or the pot, or perhaps both. Okay, I've replaced the fixed resistor and I've managed to get the trim pot back into operation. As you can see there on the 10 volt range, it's quite close. And if I just check the other ranges, 1 volt range, well, that's actually quite far out. 100 millivolt range, that's not too far out, that's pretty good. And the 10 millivolt range, yep, that's pretty good. And what about the 1 millivolt range? Yep, that's spot on. So there's one range which is actually quite far out. So let's take a look at the schematic again and find out what could cause the 1 volt range to be so far out. And the 1 volt range is on switch position 2. Here's 2 here, and if you follow that down, there's 2 fixed resistors. There's no potentiometer for that range. And it looks like it shares the same 2 resistors on this bank anyway as the 1 millivolt range. As you can see the line here, and all it does is come down with 2 resistors down onto this common down here. And that's 110 ohms in series now, and it's gone slightly under, but I should be able to adjust the calibration pot that affects all ranges just to bring it back up again. And it will mean I need to recalibrate the pots to the other ranges, but hopefully that should be no big deal. Okay, so how about linearity? Well, I'm on 10 volt scale. I've got it calibrated perfectly. Let's double check the 0. Yeah, that's not too bad. So let's go to 1 volt and see what we get there. Miles out. 2 volts. Miles out in the opposite direction. 5 volts. Miles out. 9 volts. Miles out. Well, there are 2 possibilities as to the problem with the thumb wheel switches. And that is either the resistors are out of tolerance now. I mean, remember, they were fitted in 1975. And or the contacts within the thumb wheel switch itself are oxidized, corroded, etc. Or a combination of the both. Okay, I've pulled the first thumb wheel to bits, the most significant digit. So these are all the resistors here. This red one here is actually There is a slightly different spec resistor there. I think that's a 1% one, and all the rest are 0.1%. And you can see the absolute value of each of those resistors that I've measured with my 6.5 digit multimeter. Now I did null the multimeter, and they're all 0.1%, so therefore the high end should be 1.001 ohm and the low end should be 0.999 at the 0.1%. And there are the results there, and you can see that some of them fall out with that 0.1%. And what's curious, there's some orange paint marks on all of the resistors. Now I think that Time Electronics put these orange paint marks on those resistors as they matched them, so that each thumb wheel switch got as close to a value for all the resistors as possible. Well, that's the new resistors fitted. They're still 0.1%, but they're a bit better spec when I measured them than the ones that were fitted. So now I'm just cleaving off the tops of that melted plastic that's holding in the actual PCB, and I'm going to remove the PCB and clean up the tracks that are on it. So here we go. And there we go. And that is the inside. So yes, it does look like it needs a little bit of a clean up. And also, there's the contacts. They're double contacted by the looks of it, so I'll give them a clean up as well. Now there does look to be wear marks where the contacts have been in contact with the metal surface. And now the fiberglass pen, but very lightly, because I don't want to take that gold coating off. Let's see if you can see that. I've done one half of it now, and if I get the light right, you should see it's darker down this side compared to this side where I've just used that fiberglass pen. Yes. And I'll put a little drop of super glue just on those tips there, just to hold it in place. Okay, that's the thumb wheel switches renovated. New resistors all fitted, and the internals all cleaned up and put back together again. And I've just this minute put it back into the unit, and I've done a little bit of a recalibration, not totally accurate, but enough to get there. So let's see if it's made any difference. So I've got it set to 9.9999 in the 10 volt range, which you can see here, just under 1 digit out. So that's fine, and I'll just check the 0. I've got the meter in auto mode. And yep, the 0 is okay. Now let's try 9 volts. And that's already looking a lot better. 8 volts. Yes. Now bearing in mind, this last digit doesn't really count because it's 4 digits here, decimal points here. That's looking pretty good. A little bit out there. Again, that'll be the tolerance of those resistors. I only use 0.1%. So let me try an oddball voltage, 9.876.5. Perfect. Spot on. And if we go to maybe one of the other ranges, try the 100 millivolt scale. 98.765 it should be, so it's a little bit out, but you're down in noise there. And how about the 10 millivolt scale? 9.87, yeah, 1 digit out. And 1 millivolt scale should be 9876 after the decimal point. Again, we're way down in the noise. I'm very happy with that. Let's reverse it. Yep, negative. Brilliant. Okay, I've just gone ahead and added in another bank of 6 NiCads at the back there for a total of 12. So we're looking pretty good in terms of capacity. So I think we're actually ready to put this thing back together again. So there it is, that's it all final assembled and looking pretty good for an old 1975 era voltage calibrator from Time Electronics. And I'm going to keep this one, I think. I'm going to run it for a while, maybe about a week, something like that. Let the batteries fully charge, let the analog circuitry, etc. all soak in again and stabilise. And then I'll probably just pop the front cover off. Real easy to do. 4 screws, and you've got access to those potentiometers just to do some light recalibration. So that's it for this video. Thanks for watching. Don't forget to like and subscribe. It really does help the channel grow. And if you want to help more directly, then you can always donate via PayPal or Patreon in the links below. Plenty more repair videos on my channel. Check them out, and thanks for watching.